On this episode of Natural Light, I'm sitting down with Dr Colm Flanagan, the founder of Hiroco. Hiroco is a development company pioneering AI solutions in industries like third-party logistics. Hi, I'm joined by Colm Flanagan, the founder of Hiroco. Colm, welcome.
Thank you very much. Delighted to be here, Nick.
Fantastic. Now, Colm, I really want to get into what you do day to day and what your business does. But before we go there, I want to start from the very start. You're originally from Dublin. Let's start there. Tell us about the early days in Dublin, your early university days, and then coming over to Australia.
Yeah, sounds good. Yeah, I went to did my undergraduate in Dublin. Grew up in Dublin, so it made a lot of sense. And did my undergraduate initially in electronic engineering, and kind of just sort of accidentally fell into the space of AI. Like, it wasn't something I actively sought out. It was towards the sort of the latter part of my undergraduate degree. We were all just getting assigned random undergraduate bachelor thesis. I happened to get assigned one on robotic sailing and autonomous sailing. And that was kind of my first introduction into robotics and into the field of AI in general. And that was about 12 years ago. So I've been working in this vertical for quite a while now, certainly before the present day hype kicked off. And yeah, I've worked in robotics labs right across the world and worked in AI labs right across the world. I've been working in the industry with my own company for probably about 4 years now, I'd say. So it's been a whirlwind ride, but absolutely love the domain, and delighted that people are finally starting to take a bit of notice about it as well.
Yeah, tell us about those earlier days, 12 years ago. Like, what the view around AI was back then, and what it was like. Obviously, we've seen like a massive boom, and everyone's talking about it now, but that's only happened in the last couple of years. Prior to that, it was something that was relatively tucked away, and no one really talked about.
No, they really didn't. AI has been around for quite a while, right? It's not a new concept, and I think people are now starting to realize that AI is being kind of existing in the background of their lives for quite a while. But to say, people weren't really aware of it. It wasn't something that was front and center for most people. And oftentimes you'd open up with, do you know what AI is, as a kind of an opener to try and tell people what it was that you were doing or what you were working in. That's clearly not something you have to do anymore. It's probably one of the most talked about industries of this century, if not the last, God knows how long. So we really have seen that transition from people who were just oblivious to it, didn't really care about it, didn't even know it is existing, right up to nowadays where it's pretty much the only thing anyone can talk about. You open up LinkedIn, it's the only thing you hear about on LinkedIn. You open up any of the newspapers, you'll see articles on AI. You're not going to have to look too hard. So it really has been a complete transition from the public perception side of things.
Yeah, and then so you did an undergrad degree over in Dublin, and then you did a PhD here in Australia. I think it was on a robotics PhD. But I think before doing your PhD here in Australia, you also studied elsewhere, Tehran.
Yeah.
Are you able to tell us about that and your experience there?
Yeah, no, towards the end of my undergrad degree, I got offered a job out there. It was obviously a bit random. It's not the kind of the usual place that most graduates try and seek out, but I thought it'd be an interesting one. I didn't give it a huge amount of thought, to be honest. Sort of just said, I'll give it a go. Before I knew it, sort of had my flights booked, my visa secured, and I was living in Iran. And Iran was a phenomenal experience for me, both culturally but also professionally from that perspective, because they are a country, and they were a country, and they still are a country under extreme sanctions, and they find it really difficult to get very basic things in there. So when you're working in a robotics lab, contrary to what I've seen before and to what I've seen after, whereby if you need different parts or different equipment, you just put an order in and it's delivered to your lab a couple of days later. That's not the reality. They have to understand how everything works from first principles, because a lot of the time they have to build those things from first principles. And so from a professional development side of things, kind of really instilled this appreciation from building from first principles. And that's something we try and do today at Hiroco as well. And some sort of the part of the company culture we've tried to build.
Colm, you've talked about first principles. Okay, can you give us some examples of what first principles are and make that relevant to what you have been doing in robotics?
Yeah, I think, to be honest, you do hear an awful lot of the term first principles, and it's probably used quite loosely in many respects, and there's probably not one agreed on definition. For myself, it really just comes down to building from scratch. So if we were to look at that example that I had, whereas back at the robotics lab in Iran, when working on robotics systems in Australia, the hardware is largely provided for us, and so all of the different processors and computer chips that we use to actually make these things do cool stuff is available to us, and so we can just build on top of that work that's already done. It's not available in Iran. They've actually got to build all of that stuff from scratch, including the physical processes that are used that power these systems. So absolutely everything is done from scratch and in-house. And it's that sort of build from first principles mentality. Now, it's not always practical. You can't always try and build absolutely everything from first principles, nor is it always really relevant. But it was very interesting to see how they approach problems vastly differently to how we try and approach problems over here. A lot of the time when I'm trying to approach a problem, I work on the assumption that a lot of the crap is going to be done for me. A lot of the stuff that I really don't want to have to get into will actually be done for me. And I didn't really have that appreciation for how you can think about things really right back to their roots until I sort of went there and saw that they had no choice but to do that. And so every time we try and do something at Hiroco, I try and sort of bring it back to an appreciation for first principles, even if we can't directly build from first principles ourselves.
I was going to say, within robotics, you talk about the constraints you saw over in Tehran. Do you think that, like, the actual underlying constraints of having to build from the ground up creates awesome innovation, and that's where actual breakthroughs come from? From the perspective of, you've got to rework the system, you've got to build it from scratch. And that mentality around those people in the labs is what creates breakthroughs?
Yeah, I think it probably does. I mean, you certainly had a much broader understanding of every part of the system for every person in the lab, right? Because they all had to sort of be across absolutely everything, because if something broke, it was on them to try and fix it. And they had to understand really from the software right down to the hardware how every component of this pipeline of a robotic system operated, because, as I said, like they couldn't really rely on external supplies coming in and being able to address these problems for them. So everything, and it did instill this much greater understanding of these systems holistically right across the board. And of course, if you have a better understanding of something right down to the very physical way in which they operate at the lowest level of understanding, yeah, of course, you're going to have innovative breakthroughs. I mean, you do see an awful lot of innovative breakthroughs coming from Iran. You mightn't hear about them as much as you would from other countries, because an awful lot of it either would remain in Iran, or it just isn't something that they find it that easy to promote on an international scale. But yeah, it's an incredibly innovative country, and you do have phenomenal technological development coming out of it.
Fantastic. That's very interesting. Now, what I want to do now is I want to look at your journey here to Australia, talk a little bit about the PhD that you did, where you did it, what you studied. I guess from also as well, when you landed here, was it around the sort of 2020 mark, or was it post-COVID or prior to COVID?
It was pre-COVID. I came here so I left around early 2017, pretty much came directly to Australia from there. So I've been accepted at the University of New South Wales the year before that. So I had came out here to do my PhD. That sort of started around 2017, and I've pretty much been here ever since, to be honest. So it's pretty safe to call it home at this stage.
Fantastic. And with your PhD, what did you study, and what were some of the findings?
So my specific research was in the field of cognitive robotics. Now, again, cognitive robotics is one of these things where there's quite a few definitions that are sort of thrown around for it, so it's not really got any agreed on understanding as to explicitly what it is. In my personal understanding, a cognitive robot is one that can learn through observations and interactions with its environment. So something that would be sitting here, watching the two of us have a talk and trying to infer an understanding as to what the significance of that event means in relation to what might be expected of it. So applied to a domestic context, how can it actually help in general household type contexts?
So Colm, how did you end up here in Australia from Tehran?
So before I ever went to Iran, I was accepted into a PhD program at the University of New South Wales. So I had that sort of natural transition sort of lined up, if you like, and didn't really have to think too hard about that. So I left Iran early 2017, came here around February, March of that same year, and started the PhD from there, and been pretty much here ever since.
Fantastic. And your PhD, what was it in, and what were some of your findings?
So it was in a field of AI, sort of known as cognitive robotics. Now, again, there's a little bit of argument in the community as to exactly what cognitive robotics means and what a cognitive robot is. In my personal opinion, it's just a robot that can learn through interactions with its environment. So if you look at, I mean, one of the main motivations and one of the things that people don't really realize about artificial intelligence, more broadly speaking, is just how closely connected it is to our own cognition and the philosophy of our own cognition. And when we're trying to build out AI systems, very often what we look at is we look at a specific cognitive function that we as people have, try and hypothesize as to how it might work, implement it onto some kind of an artificial agent or system or a machine, and then evaluate that on a very specific problem instance against how a human would perform. So if you looked at what my specific research was, it was looking into episodic memory. So it's kind of largely agreed that people have 3 different types of memory. Now, again, there'll be others out there that will disagree with this, but if we look at it from this perspective, there's episodic memory, which are just events that we can remember, right? We can recall the time, recall the place, a lot of the context that surrounds it. Semantic memory is just stuff that you know. You know that Abraham Lincoln was the president in 1860. And declarative memory then is all around how you can physically move in your environment, right? It's your own understanding of and awareness of your physical space and how that works within the context of the environment that you're in. What my research was looking at was how that you can sort of transition that episodic into semantic memory, right? So we're sort of hypothesizing that at some point, all of the semantic information that you have up here, you had to learn it, and that event of learning it was itself an episodic memory. At some point, you were in school, you learned the fact that Abraham Lincoln was the president of America, and at some point in time, the act of learning that was an episodic memory. But over the course of your life, you've heard that fact so many different times that you've managed to induce a more generalized understanding of what's relevant about that fact. And so the episodic memory sort of transitioned into a semantic memory, and now it's just stuff that you have. And so I was looking at that bridging between, is there a transition between our episodic memories, and from multiple observations of similar types of events, can we induce more generalized representations of what's relevant about those events, which then become part of our semantic memory. So we have this more intuitive way of how we can understand the environment, how we can interact with the environment, but of course all of that's applied to a robot, so an artificial system, as opposed to how we actually go about it.
Yeah, and in terms of like the underlying findings from your PhD, was there any like overwhelming trends or anything that was really evident from your studies?
So yeah, there were. Yeah, I mean, we were able to show that, you know, through sort of process of inductive reasoning, you could, with a sort of a human-guided approach, train these robots to understand more generalized instances of specific types of events, and how it can then learn to recall new instances of those types of events based on the generalized policies that it had learned. So in that context, what we were trying to really apply to was how robots can exist in domestic environments more intuitively. So if you have a robot that's a helper robot operating around your house, we wanted to see, well, instead of having to explicitly encode every single behavior that it needed to understand in order to function properly, could it try and learn them in a more generalized way? So for example, if you and I were sitting at home and we're having the same conversation, and let's say, what time is it now? It's 20 to 12 on a Tuesday. Let's just say it observed that and said, okay, Colm and Nick sitting here having a chat. It's 20 to 12 on a Tuesday. They're in the studio, and it takes all that information into consideration. And then it would have, let's say you give it a second instance of that same type of event, but we change a few a little bit of the context of it. So we're no longer in the studio, but we might be somewhere else. It will start to eventually realize that actually what's relevant here is that you and I are just having a chat. And maybe what it might then observe from that is sort of a sequential series of events that relate to that. So we've got a bottle of water here, maybe we were drinking some coffee. It might anticipate in the future, well, if Colm and Nick are sitting here having a chat, they usually try and have a cup of coffee. So I'm just going to go and get that coffee. And so it's trying to learn those more intuitive behaviors through these generalized policies from just observations with its environment, which goes back to what a cognitive robot is, at least in my opinion, in the first place. It's just that interaction with the environment, observations of just sort of natural things that happen in the environment, and how it can pick up on cues and try and learn more what cues are more relevant than other cues in very specific contexts, so it can anticipate its required behaviors a bit more intuitively.
Fantastic. And I've got to ask you, based on your PhD findings, how far off are we, in our households having a robot that, does household chores for you, takes out the garbage, and does these type of things?
Yeah. Look, I think we're a little bit off. I think there's a few things that are sort of stopping it from being widely adopted technology. One, I don't think we've really fully worked out how not to make these things cumbersome. Like if you look at the environments that robots are deployed in at the moment, you're looking at sort of defense, mining, warehousing. These are environments with big open spaces. It doesn't really matter if their motion planning is a little bit cumbersome. In a house, you can't have robots going around knocking shit off the tables and damaging stuff. And yeah, we just haven't really fully worked out how to get them quite as flexible as they need to be. But the other thing that we haven't really worked out is how to get them cheap. These things are still expensive, right? So I mean, it's really for the sort of top wealthy of the wealthy that can actually afford to have these things. And yeah, I think in terms of a widespread, generalized adopted technology, we're probably a little bit off yet.
Yeah, and also like getting the cost down Is that just like a mass production thing, or do you think like there has to be subsidies to bring the cost down of these robots in time based on what you know about the supply chain?
Yeah, it's probably a little bit of both. I think we'll probably start to see them rolled out in environments that are a little bit more relevant sooner rather than later, and that will come through subsidies. So, I mean, if we eventually can kind of crack this problem of motion planning so they're not cumbersome and they're quite able to make their way around household environments without causing too much damage, I think we'll probably start to see them deployed in hospitals, and we might start to see them deployed in-house for people who otherwise would require 24-hour support, and that's all going to be subsidized, and that will probably start the transition from what is really now just a field of research into something that's adopted a bit more consistently. But I think even at that, we're probably a little way off.
So, Colm, you finished your PhD. What did you do after finishing your PhD?
Well, there was a bit of an overlap between the PhD and the company. So I didn't actually finish the PhD formally until about 2022. So for the last year of my PhD, I was sort of working on the company on the side. I mean, I think one of the main, I'd always sort of just thought that, I'll get this PhD, get a really good qualification, take it off somewhere, maybe get a job in the US or in Europe and go and try and work in this domain for somebody else. But what I was starting to see throughout the PhD, we had a really good lab, right? We were producing some really good research. And I wasn't just seeing this trend in our lab, but I was seeing it in a lot of other labs, that you had this really top-notch work that was coming out of it that was just gathering dust in academic publications and on shelves, and there wasn't really much value actually being extracted out of it from a commercial sense. And so I didn't want that to happen to my own research. And so towards the latter part of my PhD, I started looking into ways that I could try and commercialize some of it, if there was some actual usable application of it, because what I found as well is usable from an academic perspective, very different to usable from a commercial perspective. I mean, academics, we just try and build shit half the time because we can, and prove a point because we can. Haven't really asked the question if anybody needs it. And so I wanted to try and understand, was that where my research sat, or was there actually something that I could do with it? And so spent the first year trying to explore how I could commercialize some of this work, and then sort of from there tried to scale the business from there. So 2022, 23 was really when I kind of started to take off in what the company now is today.
Fantastic. So Hiroco.
Yeah.
Tell us about the name, and tell us about what you guys do in a nutshell.
Yeah, the name means a lot less than you might think. Like, I get asked this question a lot, like, where did you come up with the name? People think that there's some connection to Japan. There isn't. When I started the company, it was originally with this sort of idea of human-robot collaboration. And so robots, collaboration, that was the Roco bit. But I realized that you can't just call a company Roco. It just doesn't really sound great. The week before I set the company up, I was watching the movie Big Hero 6. There was a character called Hiro Hamada. I really liked the movie. I just thought, well, if I put Hero at the beginning of it, so it just naturally transitions itself. Hiroco, done. So that was about as much thought as I gave to come up with the name. People try and read into it. We've come up with several different acronyms that we can try and apply to it. In the end, we just abandoned all of them because, there isn't actually a whole lot of meaning to it. It was just something that we said sounds good. So it kind of adds that Japanesey sort of twist to it as well, which for a robotics company never hurts. And that was really how the name came about. Nothing more, nothing less to it.
So, Colm, Hiroco, what's the problem that you guys solve at Hiroco?
So the problem that we really tackle is this issue that is pretty manifest across a lot of different sectors, is how do we move stuff around? As a society, we move a lot of stuff around a lot of the time, right? Our entire supply chain is predicated on us moving stuff from where it is to where it needs to be. We don't do it very well. In fact, if you were to look at the cost breakdown of it, in any given supply chain, and supply chains, first and foremost, are about 15% of our world's GDP, right? Absolutely colossal amounts of money are spent in supply chain. And about half of that is spent at the last mile, which is just, that's an extraordinary amount of money. We're looking at trillions of dollars alone just for the last mile every single year. And at that last mile, anywhere between 60 and 40% of it is just costs that are squandered because of, contingencies introduced to planning, right? We're just really bad at planning these operations. And we end up spending absolutely colossal amounts of money every single year. So that was the problem that we decided to tackle. It was kind of a natural evolution into how we came about that problem. It was sort of through different conversations with, particularly we actually started talking with some people in the Defence Forces about some of the challenges they were facing. And the challenge that kind of kept coming up was this issue of logistics and particularly resupply operations. How do we actually figure out, given all these different assets that we have that can help us move stuff, how do we figure out how to effectively assign assets to specific jobs so that what it is that we need gets from where it is to where it needs to be. And we realize that that's not just a defense unique problem. Transporting, warehousing, oil and gas, mining, you name it. All these sectors have that exact same problem of just figuring out how to move stuff around. and really not figuring it out all that effectively. And so we came in and said, well, we can build a technological solution to this problem and try and see if we can reduce some of those expenses.
So, Hiroco, two industries you really specialize in is transport and third-party logistics. Now, can you tell us about just how big this problem is in third-party logistics, sitting within warehouse inefficiencies, right now in 2025?
I don't think people actually realize just how bad this is. I mean, if you were to do the actual cost breakdown, we'll look at the kind of the global macro figures to start, if you like. If you were to actually sort of break those costs down, the specific figure of the problem that we're targeting is $2.3 trillion. That's $2.3 trillion that's just lost every single year. And it's money that people have kind of just accepted as sort of the cost of doing business. And they don't even realize that you can massively, massively reduce that if you just plan these operations a little bit more intelligently. And if you look at it from at the more micro level, so like the individual warehouse itself, it all comes down to this sort of butterfly effect. Right, those sort of like micro suboptimalities have this huge compounding effect. So one good example is if you're in a warehouse and you've got a missed pick operation. And missed pick operations most commonly happen because when a picker gets to a location, they've got their forklift, they can only lift stuff out of the lowest rack on their pick bay. And if they get there and whatever they need is way up there, they've got to call a reach truck in to lower the thing. That could take 5-10 minutes. Right, now that in its own right might not seem like a huge problem, right? 5-10 minutes is not the end of the world. But when you actually compound that and you realize that in a large-scale warehouse, this could be happening 100 times every single hour, right across every single asset that you have, these little suboptimalities, they really add up. And it really has not just an impact to that particular warehouse, but then the rest of the supply chain. Let's say you have to synchronize your pick operations with the transport company that's going to be there at 2 o'clock. They said we need the following X, Y, and Z to be ready for us to pick up at 2 o'clock because we've got to get them to our client at 3 o'clock. And it's going to take us an hour to get there. So we're already cutting it fine. And yet all these little delays mean that by 2:45, even 2:30, the truck's still sitting there. Right now, that has a huge impact right down the line. And if you look at the cost to an individual warehouse, about $700,000 to $1 million every single year. And that's just from one type of problem that are introduced to planning. Right? It's just that one sort of task synchronization that people just get so badly wrong. And again, it's just sort of accepted as being the cost of business. A lot of people don't even realize that you can solve these problems.
So in terms of that problem, third-party logistics, you've got people at the top end of the game, probably Amazon, who run massive warehouses, and then you'd have people at the bottom of the game that are running very inefficient warehouses, and there's cost blowouts across the board, and they're probably not even aware of all of them, of any of them, really. Now, coming in from the way that you view it, like, where do you start? And how do you make these operations more efficient so there's not these knock-on effects on their supply chain?
Well, I mean, I think it does at this stage rely on a technological solution. I mean, if you were to actually look, the reason we're so bad at solving these problems is because they're really difficult to solve. If you look at any given logistics operation, take a warehouse for argument's sake. You as a warehouse manager, your job might be to figure out how to get all of the stuff. You get your order list come in at the beginning of the day. You might have 1,000 deliveries that are going out of your warehouse before lunchtime. And your job is to figure out how to get those 1,000 things that are required from wherever they're located in the warehouse onto pallets and delivered across it. You've got to figure out all that scheduling yourself. And that means that you've got to factor in thousands of variables simultaneously. Of course, we're going to be bad at doing it. So technological solutions really are the only way to go about this. And there have been attempts at doing this in the past, but it's not even an easy problem for computers to solve, right? And so even some of the tech solutions that have come out in the past still haven't really been commercially viable. They can actually take a long, long time to arrive at solutions that are usable. And of course, if you need real-time operations, that's just not practical. So very often people end up guessing. It's that guesswork that is where the problems creep in. And so, yeah, I think if you're to try and start incorporating these technologies, it's first thing you need to do is understand that you actually have this problem, right? Most warehouses don't. They're kind of operating oblivious to the fact that this exists. They just sort of assume that it's the cost of doing business, that the frustration that's caused by it is just sort of standard and not really unique to any one warehouse. And that's also true. It isn't really unique to any one warehouse. But at some point, the penny's going to drop as to just how much money you're losing every single year. If you're a warehouse operator, if you're a transport company, how much money you're losing every single year to just these little inefficiencies introduced as we try and move stuff around.
Yeah, and Colm, how do you leverage your robotics background and your robotics skills within AI to fix these problems?
Well, so multi-agent orchestration is the type of AI technology that we use, right? Now, a lot of that stems out of robotic theory, right? Because if you have lots of robots all working together, you have no choice but to have some sort of a technological solution sitting over the top of it, trying to orchestrate and control all these things, well, because they don't speak the same language as you. You can't just call out to one and say, you do this, you do this, you do this. You have to have something that's able to communicate with robots in a way that they understand and dispatch different actions and different task requirements to them. And so a lot of the theory around what we developed stems out of robotic theory. So it's an extension of some of the work that I was doing in my PhD, particularly the work that pertained to multi-agent systems. Now, what we realized is that in order to solve this problem, your agents don't need to be intelligent, or they don't even need to be artificial, right? The issue of coordinating agents is one that is manifest just about everywhere. It was first tried to be solved in the robotics domain because we had absolutely no other alternative, but the actual core underlying problem is pretty much right across the board.
In a warehouse, who are the agents when you talk about agents and the inefficiencies?
Yeah, I think it's a good question because we're hearing a lot now about agents within the context of AI, particularly AI agents, which are these chatbots that exist in your computer and do really cool things for you. And that definitely is part of the definition of an agent, but we kind of try to extend it a little bit. And the way I look at an agent is I just look at it as anything that can meaningfully affect change in your environment. So if you're in a warehouse, your agents are your forklifts, they're your reach trucks, they might be your robots, they might be your staff, your people, whoever's actually working there. If you're in a transport company, your agents are your trucks, your vans, your cars, whatever you actually have available to you that can help. But if you really want to generalize the concept of an agent, you can apply it to any environment. Look at a football pitch. All your players, they can meaningfully affect change within that context. They're your agents in that particular context. So we've just expanded the definition of what an agent really is. And when we talk about an agent, we just have this idea of it's anything that can do something for you. And so when you look at it from that perspective, you're no longer looking at a warehouse that's being operated by robots, or you're no longer looking at a warehouse that's being operated by forklifts or by cranes or by reach trucks, or a transport company that's been operated by trucks and vans and other kinds of vehicles. But you're looking at all these things as just operations that have agents with capabilities. And those agents can do things for you. And depending on what you need them to do, you can plan them effectively, you can plan them ineffectively. And our technology is designed to plan for them effectively.
Now, you've talked about the 2.3 trillion that's burnt within last mile logistics, third party logistics across the world. When embracing your solution and your technology, on a warehouse by warehouse or company by company basis, what are some of the efficiencies you've seen and the improvements you've seen across that warehouse and across that business?
I mean, look, it mostly comes down to cost reduction, right? If you can eliminate these little problems that were creeping into it, you're going to make things an awful lot cheaper to operate. But it's not even about just sort of, because there are sort of two ways in which costs are squandered at planning, right? There's one, plans that just don't work, and then there's two, plans that coincidentally work but are really bad, right? And they just haven't got all these optimalities built into them. And so our technology tries to address both sides of that problem. So one gets you plans that work, so it tries to minimize all that stuff, or try to eliminate all of those problems. But then two, actually figures out, well, once we have plans that work, what are the best ones of those plans? How can we more efficiently coordinate the actions of these agents? Right, route them to very specific ways, get them assigned to very specific jobs so that we can minimize maybe our energy consumption, or we can minimize the total time that it's taken to do these operations, and thereby minimizing the costs right across the business. We saw in a few of the different pilot studies that we're doing, we could reduce operational costs from like 25 to sometimes 75%, right? And that is not insignificant. If you're a company that's blowing $1 million a year just through inefficiencies, saving 75% of that is pretty substantial to your bottom dollar. And that's the difference between profit and loss.
And looking out sort of over the next 5 years, obviously technology never stays stagnant. It's always evolving, it's always innovating. You've been on the coalface of that, having done a robotics PhD. Where do you think this technology ends up, just looking out 5 years? 10 years probably too long into the future, but 5 years.
Are we talking about AI technology in general?
AI technology, within the use case for Hiroco, so within warehouses, third-party logistics, and AI technology, yeah.
Well, I mean, I think if we're looking at, I'm not the only one that's kind of done the sort of the market analytics on this. There are companies that are far more qualified to do it than I that have done really extensive market analytics on this particular problem that needs to be solved in the supply chain. There's one that I'll refrain from naming just for confidentiality reasons, but they estimate that about 75% of companies that operate in the supply chain sector, whether they be transport companies, warehouse companies, whether they're operating the supply chain of a mine or port logistics, wherever it is, are going to have a requirement for multi-agent orchestration. And that's largely driven by the more increased adoption in automated technology. So like robotic technologies, when people are now realizing that they have no other alternative but to have some sort of technological solution sitting over the top trying to control all this sort of stuff. And then by proxy realizing that, hang on a second, this problem's existed for years. This is actually solving a huge amount of our issues, not just the issues that relate to our automated systems. So I think in that regard, we're going to see really mass adaptation of this technology stack in the next few years. And I think, yeah, it has massive potential to change how our supply chains operate, and massive potential to change how efficiently we can move stuff around. Which is significant. And that's really what AI is designed to do, right? It's designed to improve on things that we're already doing and just doing them better.
Yeah. Well, a bit of a macro question for you. One of the issues we struggle from here in Australia is productivity. In terms of our rating on a global scale, it's nothing to be proud of. With these adaptations of AI, do you think we can have a real sort of step change here in Australia in terms of our productivity, and as a result, GDP and how we're viewed on a global scale?
Yeah, we definitely can if we adopt them, right? I mean, I think one of the problems that we have with Australia is not just that productivity issue, but it's quite a risk-averse society, right? So we tend to be one of the latter countries that actually started adopting these newer technologies. And so if we can adopt them and we can actually sort of throw a little bit of caution to the wind and start moving a bit quicker with bringing in these sort of innovative new solutions to these problems, and yeah, absolutely, we'll start to see significant progress. But if we sort of follow the common trends that we've seen throughout and we're lagging 5-10 years behind the rest of the world, then that gap between productivity is only just going to extend, right? Because what's going on out there is going to be so much more productive than anything that we could possibly hope to achieve here while we're not adopting these technologies. And so that productivity gap, if it's sitting here today, this is going to be there in about 5 years. Yeah, so we need to make sure that we actually do have the appetite to take these technologies on and to be the sort of the market leaders in taking them on, not to follow what we've seen happening elsewhere, not to play it safe and see how's it going to work over there and how's it going to work over there and how's it going to work over there, because that model is no longer going to work for us. If we wait to see how's it going to work over there, by the time we take this on, what's happening over there has just accelerated beyond what we could possibly hope to achieve again. And so we're just going to be constantly chasing and following that up, or chasing our tails in that regard. Like previously, technological advancements were a lot slower. We saw relatively steady technological advancements throughout the sort of the 19th and even early 20th century. And we had the ability to sort of sit back and go, let's see how that works, right? Because things were moving at a much slower pace. And so we could kind of validate that, yep, that works over there. We can now try it over here. That's no longer a model that's going to work. By the time we've worked out that, yeah, it works over there's ditched it. It's now legacy technology over there. And so we have to be at the forefront of adopting these technologies. We have to get rid of that risk-averse approach that we take to this as well.
On the innovation and on just embracing AI, where do you sort of see the risks? I know that Elon Musk, to bring him into this conversation, has talked about, AI, if it keeps innovating, it could be at a point where there is a small risk of it becoming conscious and potentially doing things that aren't initially intended. Like, do you see any risks there, or do you just think the actual pros outweigh the cons and we just got to go for it?
Yeah, there's definitely risk with AI. There's risk with every new technology. And that's no different with artificial intelligence. I think that, look, Elon Musk does an awful lot of talking, and we can probably get into that in a bit more detail. But in terms of this sort of conscious and super sentient AI, I think we need to park that conversation, right? I think we're actually a long, long way off that, and I really don't think that's as much of a threat as it's maybe being made out to be in the media. I think really what we're more likely to see being a problem is people's inability to effectively and responsibly use AI, right? We have these incredible technologies out there at the moment. Nobody really seems to understand how best to apply them. People are kind of just guessing, and yeah, they might get away with it for 6 months, a year, but if they've applied these technologies wrong, then all of the underlying benefits that they think they're getting are actually just sort of superficial. And we may start to see in a couple of years' time some really significant challenges coming out of all of that. Now, having said that, if we can actually understand how to apply these technologies properly, and it's a game changer, right? It's absolutely, and in that instance, yeah, the pros massively outweigh the cons. And the amount of productivity and progress that we can make by effectively adopting AI technology is insane. It's just, my concern is that people aren't really effectively adopting it. They're applying the wrong solution to the wrong type of problem that they have. They're not really understanding that AI is not one thing, that it's actually this multidisciplinary field with lots of different types of solutions, each uniquely positioned to solving lots of different types of problems. And sort of blindly picking one, saying, "Oh well, yeah, I can get ChatGPT to do all my stuff." So you can't, right? That's might come as a shock to a lot of people, but ChatGPT cannot do everything. It's actually a very narrow, targeted type of AI. And if you start to try and use it to solve all of your problems, I'm going to give you very convincing, but logically completely flawed answers to those problems. And if you start to adopt those recommendations and start to adopt what these things say blindly, you're in a lot of trouble. But what is quite likely, and what people don't realize, is that the problems that you have probably do have a solution that was specifically built for that problem. So you just need to first of all understand, what are you trying to solve here, and then go out and find the correct solution for that. If you can do that, the benefits that you get from AI will just be absolutely monumental. And the improvements in productivity that you will see will be absolutely colossal. So that's really where I think the threat from AI presents, is that people don't know how to use it properly. They don't know how to use it responsibly. And that's going to be an issue.
You're talking about the biggest challenge for embracing AI. Now, if we look at this through the lens of small business, Australia's, the small businesses are the engine room of Australia, and a lot of them aren't doing so well at the moment. How do they properly understand their challenges and go out and utilize AI to solve them, beyond just being overly reliant on something like a ChatGPT?
Yeah, it's a pretty good question, because actually trying to understand where you have issues in the business is not as trivial as it sounds. But what you'll find, so I mean, if you look at the definition of what AI is, right, it's the field of study concerned with building machines that think and act like people. A lot of people don't even seem to know that as a fundamental definition to it. And so if we're trying to build machines that think and act like people, well, really, what you first and foremost need to do, if you're trying to work out how to apply it, is look at what you're currently doing and analyze, how are you currently solving it, right? What is the process that you take to get yourself from a point here, which has got a problem, to solution, right? You're doing it constantly on a daily basis. And if you actually analyze that process, you will probably find that there are several things that you do along the way. Now, to some of those things, you might find that you can offload a lot of it. You could possibly automate parts of that particular process that you implement every single day. And so in that regard, we're not trying to reinvent the wheel with AI solutions, but rather we'll just plug them into different places to replicate one core part of that process that you can then divert your attention elsewhere. You can offload a huge amount of the work that you otherwise didn't want to do, that was otherwise getting in the way of some of the more relevant things that you're good at and can actually provide value, but otherwise you find yourself unable to do because you've got all this other shit that you've got to be dealing with. And as I say, yeah, just try and actually articulate clearly how it is that you're doing it presently. What does your business do? What are the daily activities? When you get into the office in the morning, write down a list of things that you do. You answer emails, you make coffee, you analyze some reports, whatever it is that you happen to do. Actually document each of those. And you'll start to find that consistently, if you do that, every single day, you'll probably find that there are some fairly consistent things in your day-to-day operations that constantly come up. And you'll probably find there are some fairly consistent things that constantly cause you headaches. And it's those things that you may find you actually have some solutions for. But you need to make sure you get the right one. And because again, if you just offload some of these problems to AI and it's not the right type of AI, you're going to spend a hell of a lot more time in 3 weeks, 4 weeks' time trying to unwind all of those problems again.
So one of the biggest risks, Colm, that we hear about with AI is job loss, and that AI is going to wipe out, the whole labour sector in various areas, and we're going to see a big spike in unemployment. I want to get your view on, where you see that, what you think will happen there, how you think AI will, I guess, affect the unemployment rate, and how the labour force will continue to evolve.
Yeah, look, there will be some roles and jobs and industries that will be made redundant by this, right? I mean, there's no two ways about that. I mean, we're probably starting to see it in some sectors, even right across Sydney at the moment. We've got a fully automated train system, right, that can operates pretty smoothly without the need for a driver. So there are things that will eventually be phased out, right? But What I would say to that is that whilst it might seem scary, and sure, it definitely isn't, I don't mean to trivialize the problem at all, because for some people this is a very, let's say, stressful time because they're looking at their own sector and going, am I going to be impacted by this? I don't think we're going to see it as rapidly as people are making it out to be. I think it's going to be a much more gradual transition where some industries will all of a sudden start to see irrelevance because we can automate a huge amount of it. But what I would say to that at the macro level is that this is not the first time we've seen this. And throughout history, we've always introduced new technological solutions that have improved the productivity of certain sectors, and in doing so have meant that people working in those sectors were no longer required. But what we saw coming out of that is a whole host of new industries and sectors that were developed, right? So we're not going to ever be in this situation where people are completely irrelevant, right? There's always going to be roles for people, and I think actually what we might find is that there's even more future employment for people after this sort of post-AI revolution, if you like, because we are going to start to see new sectors coming out of it. And I can't really say for certain exactly what we're going to start to see coming out of it right now, but I know that in 20, 30 years' time, there are going to be things that we do today that we're no longer going to be doing. But by the same process, there are going to be things that we're not doing today that we're definitely going to have people doing in 20, 30 years' time, because this is what happens. We can look at every single technological revolution in history and see the exact same pattern of behavior. We see that people don't like new technologies that came by. People didn't like the spinning wheel when it came by, but it was extremely helpful in the production of producing clothes, so it stuck. And we saw other industries develop post that industrial revolution. We saw economic prosperity right across the board. We saw an all-round a higher standard of living. So we've seen these patterns of behavior before. Seeing people being stressed about the introduction of new technologies, seeing them being stressed about how that relates to their own employment and what they do. And I'll say I'm not trying to trivialize that. That is certainly something that people are going to be feeling the pressure on right now, and justifiably so in many cases. But yeah, at that macro level, I don't think we're going to see this mass unemployment, because we're going to see other sectors evolve out of this, and we're going to see other uses for what people can do.
One question I've got just around AI data and training models. There's a lot of talk at the moment around synthetic data, and I know that Grok AI is training a lot of models on synthetic data, whilst other models are relying on all the data that's out there in the ecosystem. Do you have a view on these AI models and the training of models and who potentially wins that arms race? Or do you think it's largely irrelevant? It's not going to be a winner-takes-all market?
Yeah, I don't think we're going to see a winner-takes-all market. I mean, we've already started to see, the emergence of hundreds and hundreds of different AI companies, right across the board in almost every single sector. So I don't think we're going to see a winner-takes-all for the AI sector. It would be a bit like saying we're going to see a winner-takes-all for the medicine sector. We're going to, somebody's going to develop a pill that cures every single illness. Not going to happen, right? There's going to be lots of different companies out there, all building lots of different types of things and having their own unique position in that regard. So I don't think we're going to see that. I mean, in regards to sort of the data that are training these systems, I mean, look, there are certainly things that need to be considered, and there's challenges to using historical data, because of course, as we train things on historical data, those data points have all of the historical biases that were included in those data that might not necessarily be relevant to how we do things today. But of course, AI systems are objective, right? They're not subjective. They can't actually understand that what it's producing here mightn't necessarily be in line with how things are done today, because it's working off what it saw in the past. And if what it saw in the past is no longer what's done, that could be potentially a problematic output. So I think, we obviously need data to train machines, but it comes with its challenges. And those challenges are going to be things that we need to constantly try and work around.
Fantastic. Now, Colm, you live in Sydney. When you're not, head down, bum up at work, working on robotics, what do you do for a bit of downtime? What makes you tick?
To be honest, I mean, the 2 hours a week that I get when I'm not working on AI or thinking about AI. I mean, look, I came out to Sydney because Sydney's probably got one of the highest standards of living in the world. I mean, you really can't beat it. I mean, you look outside, it's the middle. Okay, it's not a great day. Today's a terrible example. We'll look at yesterday, right? It's the middle of winter, beautiful sunny day. I mean, like, it's just, you can't really beat it. I mean, in terms of a lifestyle city, it really does tick all the boxes. I mean, if you go into Coogee, there's probably about 600 million other people with my accent walking around, and it's for a very good reason. It's we come out here for a lifestyle, and it really is. It's a great city. Hard to beat it.
Yeah, fantastic. I agree with you. Now, if someone wants to get in touch with you at Hiroco,
Yeah.
What's the best way to get in touch? Is it LinkedIn? Do you have, is it through the website? Like, let us know. Like,
yeah, a bit of both. Yeah, you can look us up on LinkedIn. Just type in Hiroco, Hiroco, into the search bar. It'll come up. Our website, Google us, you'll see us. Probably the best way. All the contact details for how you can reach out to me directly will be on that. We offer anybody that wants it. We offer a free 1-hour AI consultation if you want to just sort of understand how you should go about starting to incorporate AI, and you want to try and maybe avoid some of the common pitfalls that we see. We offer that to pretty much anybody that wants it. So there are links to all of those sorts of things on our website, and anybody can go on, sign up, and if you can find a time where we've got somebody available, we'll be able to slot you in.
Fantastic. Colm Flanagan, thanks for coming out.
Thanks very much. Cheers.
Cheers.